Okay, I think we're streaming. Streaming indie dev. Doing underwater stuff. Yeah, tell them here as well. I forgot to check if my audio is okay, but it looks like it's fine according to the levels. I'm sure that in an hour someone will tell me whether I've got robot voice. I moved my mic a little bit because I was getting a lot of previously, and it was really annoying me. So hopefully we'll get a little bit less of my breath straight into the mic this time. So last episode we worked on these pop-up warnings, but we don't need them yet. We're just going to put them into storage for later. They're prefabs, so it's not a big deal. Oh, in case you didn't actually get to see that, well, no one's watching yet, but this is what they look like. If you're watching this later, you'll get to see it. So they just kind of grind for a little while there. And you can see how they just scroll like that. The point here is to make the player feel overwhelmed with error messages, and I think that that'll do the job fine, at least for now. I tried to make my own text renderer, my own shader for text, and you can see it works great, right? Look at that. It's beautiful. It's fine. In scene view, it works great. In game view, it looks like that. And I have no idea why. And I couldn't convince anybody else to tell me. Presumably they also have no idea why. So I won't be creating custom text renderer until I figure that out. Now I think that if I were to use maybe, I think I technically have the new mesh text already in here. If not, I can import it. It's free now. But I don't know anything about that either in terms of making custom shaders for that. So if you are a custom shader whiz and know what the heck's up with text, let me know. And you know, that'll be great, right? So we created a bunch of stuff. We created some, what am I thinking of? We created some of these kelp forests. We switched them over from being particle kelp. The Rowan says to use Text Mesh Pro. I mean, I can do that, but I'd have to actually, like, change everything over to Text Mesh Pro. The thing is, I need to do a custom shader so that I can freak it out according to world space coordinates. And I mean, if Text Mesh Pro has an easier interface for shaders, then I'll probably go through it and do it. But if it's just the same stuff but with a different face, there's no reason to. So these are in place now, but the problem with these is that they do not respond to players wandering through or anything else large and in charge. So what we need to do is quickly implement a little bit of a push mechanic for these. We're going to be doing something similar for many of our mechanics, many of our shaders. I guess we should start with one of the ones that's going to be most visible, and that would be the silt. So if we take a look at where our player is, we got, turn off those errors. Player's over here. There's not a whole lot of silt over there, but there's some. We'll just move ourselves to here for now. So if we take a look at silt, we can go ahead and create like a big patch of silt for no particular reason for testing purposes. But this is how the silt currently looks. And I don't know how well you can see that. The slowdown is not constant, but so this is the silt that we're currently using, and you can see how as we pass through it, we do get a nice fog effect around the character, but the silt doesn't move at all. It doesn't like push to get out of the way or anything like that. The problem is that the silt, it might not be a problem, but the silt doesn't have any concept of local space and its camera tracking. Getting the silt to move away from us in shader might have some bad side effects. Let's go ahead and try it anyway. So to do that, we're going to pull up our silt shader. We're going to go ahead and create some more silt too. There's no reason to leave it mild. We can go ahead and punch it way, way up. Should be in particle effects. Yeah, so here's all of our silt. There is some of our silt. Let's just take this silt. This silt here, we'll just move it around a little bit and punch it up a little bit until it is egregious for the purposes of testing. So now that we are like super silty, we should have a hard time not seeing the silt. Yeah, see, it's like this giant fog effect. And so what we're going to want to do is tweak the shader so that the silt will react to movement. And so let's do that. We're using a sand puff shader. I don't remember whether the sand puff shader is specific for silt, but it should be okay whether it is or not. What we're going to want to do is create some vertex offsets. Now this says local vertex offset. That is in fact a lie. It doesn't have any concept of local. It's going to be a global vertex offset. So what we're going to need to do is create a list of vector 4s, and then we're going to need to move away from them. So let's go ahead and get that started here. We could also use vector 3s, but if we use vector 4s, we can use a fourth vector. Let's use vector 3s for now. We can switch it over to 4. We can use the fourth one for radius is what I was going to say, but whatever. So we should be able to have a global array here. Just pop that in. If we make this into vector 4s, it's vector 4s by default, so I guess it doesn't matter at the moment. We've got to name it something, so we'll call it points of interest. Pushers. We'll call it pushers. So now we've got an array of pushers. We're going to have to set the array length. There is a bug. I don't know, maybe they fixed it by now, but there's a bug where if you try and set the array length on the fly, it crashes. So we're going to go ahead and do it like that. And that should be enough. The only other thing we have to do is actually do all the coding. Woohoo! So I'll keep bumping the mic here. It might be a little bit too far from my mouth. Tell me if I'm a little too quiet or a little too loud or whatever. Anyway, we're going to go and use a code, custom code, custom expression, my bad. The custom expression is going to take a value in. We're going to go and tell it to take in a value 4. Now the reason, this is a little bit strange because this is actually not something we give a shit about. We're not going to actually be using it for anything. We do that so that the global array exists. If the global array isn't properly linked into the command chain, it won't be compiled. But we also need to have a vector 4 for our world position. Boom, like this. So I guess we should use vertex position because we are animating verts, not surfaces. No, normally this would be in local space, but there is no such thing as local space, so we don't have to worry about it. We're going to create another input. We're going to go ahead and call this one vert pause. Oh, we'll just call it pause. It's going to be a vector 3 because it's a position, and we're going to go ahead and pop that in. And this output will be a vector 3 as well, so we're going to tell it to do that. Output type vector 3. There it is. And that's going to be our quote-unquote local vertex offset. There we go. Now all we have to do is code up the custom expression, which I can never remember how to do, but we'll go ahead and give it a shot. We need to do a for loop so that we go through each of these global arrays. So for int a equals 0, a is less than 5. We can actually say a is less than... I don't know whether it's pushers.length or underscore pushers. We'll find out. It doesn't really matter. And what we're going to do in this case is we're going to need to create a vector. Sorry, it's a float. My bad. I think we can just do that. I don't remember. We'll know for sure in a little while here. We'll just go return offset. And we're just going to test and see whether or not this explodes. Unexpected token. Okay, so it explodes. Line 41. The problem is it's not line 41. It's inside of the custom expression, so it's... it might be that, but that doesn't make any sense. All right, well, I'm over on the other screen just doing some testing here. Oh, I have lots of email all of a sudden. It's nothing important. All right, so I deleted the for loop to see whether or not that was the issue. And it might have been. I'm not sure if that error is still hanging around from before or what. No. I don't know how to create a new float 3. Custom expression. What's the name of the thing? It's I need you to tell me your name. Your name. What are you? What is your name? Ugh. Amplify. Thank you. God damn. I mean, I could pass it in another vector 3 and just use that as like the resting place. But it seems like stupid to try and do that when I should just be able to type new. But I don't know what a float 3 is, and I can't remember. On expression mode, a semicolon is not required. What? Well, let's make sure that I'm not missing any chat, because maybe someone has something smart to say. But I don't have very many people watching, so it's pretty mild here. Oh, okay, so they're just using... Okay, so they're just using tuple notation, which is absolutely fine. I can deal with that now that I know it exists. Yeah, good. Anyway, now we can go through with it. Oh, for fuck's sake. This is one of the worst code editors I've ever seen. You know what? I should go ahead and pop up a new code editor. Let me go ahead and pause you for a second while that's a subscreen, while I try and get my code editor up to snuff here. I'm just going to use a simple background tool. I'm not going to bother firing up an IDE for this, because their code editor does things like constantly select the entire thing every time you click anywhere near it, which is no good. So we're going to use some cite. Tell it that we're in C# here, except we're not in C#, are we? Is this just raw C? I can never remember. Doesn't matter. We'll just pop on over into here. Okay, so we're just going to do for int a equals 0, a is less than, what was it called? Pushers. And then we'll just go ahead and say offset dot. Is it going to say offset.x? Is it going to be... Well, let's go ahead and try it, and it'll give us some errors, and we'll tweak it. I have a feeling it's capital X. It could also require me to do like an open bracket, something. All right, well, that seems to have worked. We'll hit play and see whether or not that holds up. So it's going to be hard to tell, because I used X and I shouldn't be using X. So let's go ahead and just use Z instead here. Or is it Y? Y. Because that way we'll be able to tell because it won't be at the same height. Oh yeah, that definitely worked. See, it's now quite a few meters higher. So that definitely does do the job. All we have to do now is actually program the part where it cares about the locations. So what we're going to do here is we're going to go into this and calculate the distance between these objects. I believe there is just a function called distance. So let's go ahead and try that. So float3 pusher equals pushers A, and then we say if, so this is actually us using a float 4, so we're going to have to cast it to a float 3. I think that'll work. We can always just do like x equals x, y equals y, z equals z, but I don't want to do that if I don't have to. So then we're going to just get the distance, and I think we can just use distance. And basically, we're just going to check and see if it doesn't pop up any compile errors, then we probably spelled everything fine. Because the logic here is very, very simple. It's just a matter of it being a different language, and I'm not sure whether those compile errors are going to work. Okay, so that appears to have worked. So now we've got a range here. So if our range is less than the 4th value in pushers, then we want to push away from the center. So to do that, we'll just say if range is less than pushers a.w, x, y, z, yeah, w, then we're going to want to move our offset away from the center of the pusher. So we say offset equals pos minus pusher. And that'll push us away arbitrarily far. I need to normalize this, and I don't remember how to normalize it in this language. I wish that at some point in the Unity products, in Amplify, it would just tell me what the hell language it's using. Even if you click on their highlighted thing for code, it just takes you right back here. It doesn't actually take you to some kind of list of what paracode is or anything like that. It's like, whatever. Code. Text area on which the creates a custom function. Yeah, so what the fuck is paracode? How can they be this unhelpful? They have a scripting language of some sort, and they don't even bother to tell you what it is. Now, presumably, it's like shader code, which would make it a branch of C, I think. But I don't have that shit memorized, and I can't believe they don't tell me. Let's try normalize. Offset equals normalize offset. And let's just see if it understands that. Super9 says UE4 uses HLSL. That's probably at least very close to this. Let's go ahead and just look up how to normalize something in HLSL, and that'll... yeah, so it actually is just a call to normalize. So it's probably HLSL. They could just say that at some point. That would be super nice. But they're not. I don't know why. Save that. Oh, don't save it. Oh no, you momentarily saw all of my Space Engineers scripts. Ah! As it turns out, I'm a huge nerd. I know that's going to be a big surprise for all of you. All right. Well, it doesn't seem to be causing any errors, so we've just told it to move 1 meter away from the pusher if we have a pusher. I'm going to go ahead and close that for a minute. Now we should see them no longer flying quite so high because they're no longer just adding 1 to Z. Yeah, but they're not currently responding to our position because we haven't passed that position to them in the form of a pusher manager of some kind. So we're going to go ahead and set up a pusher manager that will act as kind of a global, that way we won't have to keep creating it over and over and over. So we'll create it here in life, I guess. All right, so we can put this anywhere we want. I think we'll put it on the sun. That didn't work, did it? No. Here we are. Just gonna pop this open in our editor of choice. It'll take me 15 or 20 minutes to actually finish opening that. So I'll close some tabs and check on some background stuff to see whether or not I have a whole bunch of people telling me anything. Nobody's saying anything. That is fine. Hey, Ryder. What do you think about opening up the file I double-clicked on at some point? There we are. So it's not actually done opening yet. It's still got a lot of editing to do before it gets there. And if I start trying to type, I'm trying to type something that it's going to screw up on if I haven't finished loading. So we'll just pass the time. How are you doing? Is your code loading faster than my code? I thought so. A global class that keeps track of moving objects and passes them into materials. Hold on, I can't do it like this, can I? Nope, I can't do it like this. The reason is I have to actually know which mesh filters or which mesh renderers it needs to work with. So we're going to go ahead and try that again. In 15 or 20 minutes, Unity will finish compiling the empty file, and we'll delete it. Large moving object reaction. Why not? Have some fun with our names. There we are. So we'll go ahead and do this. Put on a mesh renderer or particle system to have it respond to large moving objects such as the player, sharks, etc. The only problem is getting this to be edited. We're going to have to make the we're going to have to make it have a way to edit these things together, and I don't really... okay, I know what I'll do. Put one on something... put one on anything you want to track as well. It'll all work out. So what we're going to do is we're going to create a public static list large moving object reaction, except that's not what we need. We need a list of transforms. Targets. We're going to need to make that a thing we initialize on our own because it's a static. Then we're going to want to have a public bool track this, and then equals false. And we'll go ahead and put in a tooltip there. If true, this is a large moving object, not a response. So in some cases, what you might have is just using two classes for this, one that tracks the object in question and one that actually responds to those objects. Another way to do it would be if you tag everything, but you can't have multiple tags as far as I remember. Can you? Let's check. Unity, I'm clicking, thank you. Yeah, so we can select the beings. We can't change the tags. You see how this is on layer beings? I could just check for all layer beings objects, but the problem is that if I do that, everything in here is layer beings. So I would have to pick like the parent object and somehow not accidentally grab other objects or something similar. Searching for layers is actually quite slow. We can add some tags. I guess since we're not using tags, it would make sense for these to be tagged. So we're going to go ahead and do that. We're going to go and add a new tag, which we're going to call large moving object. And we'll figure that out. So if we go up to the player here, we should now be able to tag it as a large moving object. So in this case, we don't need this. What we'll do is we will just track down the large moving objects. Now, looking for something like this is in fact quite slow, so we want to do it only once right at the start. And we only need to have one of them as a static list. We do not need to do this with every object because they're all going to have the same value. So here we say if targets.count equals 0, then we want to initialize the targets. And here what we can say is targets.clear, because we may be calling this surprise something. You know, we might have to call it when we spawn something in or something. But then we can just say, I don't actually know how to do this. GameObject.find by tag. Find with tag. That returns, here we are. This returns an array. So, if we come back over here, the name of it was large moving object. That'll get us an array, right? And so we can say targets.add range that. Oh, and as you can see, it helpfully randomly deleted a word that it had no business deleting. So we'll go ahead and fucking type that back in. There we go. Why are you barfing? Just do it. Why are you barfing? Oh, I'm trying to add game objects and it wants me to add a transform. All right. Game object fu equals this. For in a equals 0, for each game object f in fu targets.add f.transform. Exciting. So now what we need to do is we need to grab a mesh renderer or whatever we're trying to apply this to and figure out what we're doing. So it will probably be particles at first. So let's go ahead and create a particle system. PS. Now the thing here is that the particle system is not something we can assign a rendering overlay. It's what was called a material property block. There's no property block situation for that. We have to find the renderer here, Monk of Time says, what's the goal for today? We're making the world a little bit more reactive. We're making the silt fly around when we pass through and stuff like that. But in order to do that, we have to grab the renderer from this particle system. And I don't remember exactly where that's stored. See, there's an obsolete renderer command. Unity particle system renderer. Particle system renderer is its own thing. Render module isn't a struct under particle system. Use this class to render particles on the screen. I don't want to use it to render it. I just want to find it. Where is it located, you asshole? They left a link to that, like, ooh, we're so smart. No, you're not. Okay, so here we are. Nested down below the best answer is, in fact, the answer. Why would you do that? Just mark the answer as the best answer. There's no reason to be snarky about it. Just instead of being unhelpful and answering with a deflection to a page that doesn't actually help, just help. So here we can get our particle system renderer. I wonder if we can just grab that without... Let's try it. So if we take a particle system renderer PSR, let's just see whether or not that can actually allow us to drag and drop that in so I don't have to go searching for it. So if we come down into our sand puffs, I think it was 6 that we were working with. There it is. If we come down to the bottom here, we should be able to add in this new large moving object reaction. Boom. There it is. And the question is whether or not the particle system renderer... Yeah, look at that. So we can just ask it for a particle system renderer. And if we have one, we can use that instead of trying to find it. So particle renderer. And then we're going to go ahead and have a public mesh renderer. And we're just going to, one or the other or both, whatever. So we're going to say if particle renderer, then we're going to want to, can we apply dot property block? Yeah, so there is a set property block here. So let's go ahead and create a property block. Material property block. We're going to want to go ahead and create that as part of the initialization process. And make it protected. There we go. And that way we won't have to worry about it changing all the time. So we say mpb.setArray, and the array is called pushers, but I think it might be called underscore pushers. We're going to find out soon enough. And then we need a list. So our list is going to be created from these targets. So we're just going to say pushers. And then we'll come up here and create that. So for this, we're going to create a new vector4 array. My brain's not working too great. That's fine. All right, so there we have it. And then we're going to go for int a equals 0. A is less than targets.length. Count, my bad. Length, my bad. No. Dot length, count, whichever. I'm going to want to min that. mathf.min to. Oh, well, it doesn't matter. I'll just do it like that. And then we'll just say a is less than targets.count. And then we can do the here mathf.min targets.count 5. Because we only take 5 targets. So, Erdroy stopped in to say hello. Hello. I've got a lot of comments, like 4. So once we are going through, why is this barfing? Does it not know how to compare an integer and a float? Oh, I'm an idiot. That's what you get for not having coffee. There we are. So now that we're going through those, we can just grab it and create the vector for that we want to create. So vector for P equals targets A dot position. And then we say P.W equals 2. We'll go ahead and make that customized later. Return array. Oh, forgot to add it. Okay, so now that we can get that, we should just be able to pass it in like so. This is yellow. Oh, it's inefficient. That's fine. I don't care. So if we have a particle renderer, then particle renderer.set material property block, MPB. If mesh renderer, then mesh renderer.set property block, MPB. Basic stuff, right? So we'll go ahead and save that. And then we will shrink this down, and we will shrink this down, and we will zoom in and out until it recompiles. And let's take a look down here. We've got our large moving objects. We're looking for this. Come on. This. There we are. And let's take a look. Let's see if it has any sort of errors or what. Well, I don't see any errors, but I also don't see it really moving. All right, well, the lack of errors, the reference script on this behavior is missing. Oh, so I'm not 100% sure if that didn't work, why that didn't work. There are lots of reasons it might not have worked. First off, let's go ahead and pump this up to 5. And then let's go over into Unity, grab this shader editor here. 15 or 20 minutes. Thank you, Unity. Right now we are moving exactly 1 meter. So we're going to go ahead and multiply that by 5 and move away by 5 meters. And that should give us a substantial movement, which will hopefully be noticeable. What about assigning a mesh renderer? Well, there's no mesh renderer here. This is a particle system. But I could choose a mesh renderer, like, say, that rock there. That's not a bad idea. Let's go ahead and make that rock react to our existence. Why not? So here's our large moving object reaction. Drop it on itself here, and we'll take a look. So it's the rock behind the science stand. That rock there. I don't really see any signs. Oh, well, this isn't going to work because it's not actually... Oh, well, you see the particles moving away? That's definitely working. So the rock doesn't work because it's not using a shader that's compatible. But this is definitely working. You can see how it's driving all of the sand away. And it's pushing it away in such a way that the camera still gets it. And that's why I was confused before. Because what's happening is it's creating like a circular dome. See? So what we really want to do is have that be way more fluid and interesting. So to do that, we're going to take the difference and the closer it is to the center, the more that is going to get pushed. So here, when we normalize the value, we're not going to need to normalize it, are we? We need to invert it. The further we are from it, the less the push should matter. Give me a moment here. Oh, I just used the same class for both particle systems and for mesh renderers. So I just whichever one is active I set. So we got the offset here, and we're going to want the range on the offset. So, no, we got the range is float. There it is. So if we take the range and we divide it by pushers.w, we'll get a value between 0 and 1. That range between 0 and 1, we can then just invert and that will give us, let's go ahead and just use parentheses to keep it clear in our heads here. That'll give us a 1 when we're at the center and a 0 when we're at the edge. Then, when we normalize it, we can multiply it by pushers.w times range. And that means that it'll, I don't need you to save it to that directory. That means that it'll amplify itself as we get closer and closer and closer, which should allow us to have a much softer rollout. And anyway, we'll remove it from this because we definitely don't want it there. Removed. And we need to paste it into the material. So here it is. Just paste that in, hit save. Seems fine. See, yes, that's true, but you're not telling me how to do vector construction. Well, we'll ignore it for now. All right, so in theory, what'll happen now? Yeah, so you can see that we're getting a little bit of motion here, just a little bit of puffing. Since we set our radius to 5, it's like we're much, much larger than we are, which is giving us some silliness. We can move the radius way down, but you can see that having a little bit of action there is already noticeable. Let's go ahead and move that radius from 5 down to 2 again, just to give us a little bit of punch. And we may just change the pusher so that it pushes more aggressively or has... I guess I can't give it an animation curve because it's not a Unity object. So now that we have a 2-meter radius, we should get a lot less pushing. But it seems like we have like no pushing. See, the issue here is that these are very large objects. These silt clouds, each of the particles is quite large, which means that I may only be hitting one corner of it. I may not be doing as much as I think it's going to be doing. But I think what I want to do is I want to push them down if they're within half the radius, and I want to push them up if they're outside of half the radius. So let's go ahead and set that up. So here we can see there's a range of 0 to 1. If we have a range, yeah, so we can just subtract 1. Range minus equals 0.5. I don't know if I need to say it's f. I can't remember. We'll say 0.5 and see if it barfs. Then we have a negative 1 to 1 value. So, no, wait, we don't. We have to say range equals range divided by pushers.w, like this. And then we say range minus equals 0.5. And then we say range. We don't have to multiply it by 2. There's no point. I'm trying to think about how to do this, because if we just give this a y value, then what we're going to end up doing is creating a ridiculous like spike at the beginning and the end. What we actually need to do is use a sine wave value. So we actually want to multiply this by pi, or is it 2 pi? It's 2 pi. I don't actually know how to specify pi, but I can guarantee you it's not by spelling it pure. HLSL pi. Well, it says to use a static const. Wow, that's really dumb. Seriously, it's not pre-worked. That's really stupid. Okay. So what we've just done is we've created a sine wave value where at 0.25 it will go up, and at 0.75 it'll go down. And then what we'll do is we will simply make the offset equal to a y value. So instead of doing this, we'll just hide that. Instead, what we're going to do is we're going to say offset equals 0, 1, 0. And then we can say offset times equals range. And I'm not sure this is going to work, but we'll try it. I hope the commenting things out works in HLSL. I haven't used it very much. Yeah, so I don't know what a vector constructor is. I should probably look that up. I'll look it up after I'm done here. It's the problem with working with something like HLSL, right? All right, so we're still at only 2 meters of size, so let's just go ahead and look that up. Vector constructor HLSL. Oh, I got a sudden rush of emails. Oh, it just says to type float 3 in front of it. I'll do that later. No biggie. No rush. Someone unplugged their system. Those jerks. That's fine. So over here, we're going to go ahead and change this from 2 to 5 again, because we've changed the way that this all works. And that should just work. We'll get some sine wavy action in theory. And my hope here is that it'll sort of feel fluidy. Hold on, the sun's in my face. I see nothing. It might simply be that I stupidly forgot to... Oh yeah, we forgot to multiply it by pushers a.w. So it was only moving a fraction of 1 meter up and down, which is why it was hard to see in this particular setup. Just go ahead and open that shader editor back up here. Punch it back in. The only issue now is the signed-unsigned mismatch, which I don't know anything about right now, and I don't care, so we don't bother. Although maybe I should, because if it's an unsigned value, then wouldn't that mean that it could only go... Oh, there we are. See that? So obviously multiplying it by the full width that we're running at is way too much, but you can see the basic idea here. Once I tune it down, this should be fine. It should be something that is mildly acceptable. The only issue here is that we are using huge quads here. I'll pause it. If we take a look at what these are, if we turn on selection wireframe instead, well, we have too many of them in this location, so it's hard to see. But these are all quads, meaning they're just 4 verts. And what we're doing is we are firing one of the edges up into space. See that? And so the result is that we have the center of the quad, where the opacity is strongest, skewed. So basically we're taking like a piece of paper and folding it from corner to corner. And then we're looking at the middle of that crease. When what we should have is we should be moving the whole thing up or the whole thing down. But unfortunately, I don't know how to calculate out a whole thing in a particle system. It's just not not going to work that way. See, the problem is that the particle thing is doesn't have any concept of that sort of connectivity. There's no object center, for example. I don't know how to find the bounding box of the object. I think we're going to have to live with this. If this is what we want it to be like, we're going to have to live with it. But it's far too large, so we're just going to divide it by a certain amount. Just choose some random stuff there. Are we dithering, says Obs? Yeah, we dithering. It's the easiest way for us to get lighting, proper lighting in this. Serpent9 says, can your diver buddy also push the dust? Right now there's room for 5 dust pushers. So yes, I can set up the buddy to push it as well. I just haven't yet. All I have to do is set their tag, and it'll work fine. So right now what we're doing is we're doing a much reduced version, which I'm hoping will give us the feel without the error-stricken plumes. But the effect is so small. Dividing it by 3 was not enough, or rather was too much. We'll just divide this by 2. Yeah, so you can see that we get just a little bit of movement. You might not even be able to see that on YouTube. But this same process, the same procedure, can be used in a lot of different places. I wanted to get it started here. So you can see how it's just kind of moving in the back there. That's not quite right. See, the issue here is that when it's negative, it looks really bad. I could just make it move positive. I don't really know what I want. 5-meter radius is obviously too much, unless we're booking it. We should probably have these, be assigned to rigid bodies and use their velocity to determine the W value here. For now, we'll just bring that down to 3 and see whether that's a little bit less awkward. Let's switch off our selection wireframe. There's a little bit much. Come on. So the goal here is to create an effect that doesn't look terrible when you're looking at it from the side or, from a strange camera angle. But I'm kind of worried that that might not be possible given the constraints of the particle system. What I may have to do is come up with a new way to handle this, where if you're inside the constraint box of a particle system, you can spawn in new particles flying upwards or something. Don't really know. So I'm thinking that if it's below 0, maybe I should have it move away. And if it's above 0, maybe I should have it move up. Let's try it. Here we are. So here we can get that range is signed blah, 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 blah. If range is less than 0, then we're going to want to do one thing, and otherwise we're going to want to do the other. But I don't know how expensive this is getting. It seems like it's going to get pretty expensive. I guess we'll find out. So if range is less than 0, then offset equals this. And because it's less than 0, we're just going to invert this. Oh, don't save it. Just copy it. Hello. There we are. Now I'm trying to find a shader-based solution for this, but it might be something that would make more sense with a different approach. All right, so what we're going to do now is we're going to change out the tagged value for wherever our rigid body is. Okay, so the rigid body is actually right here. If we take a look at the player character, the only issue is I don't think that the center of the object is at the center of the character, but that's fine. So over here, what we're going to do is we're going to get the rigid body. So yeah, I'm trying to think about the best way to do this, and I guess it's just the best way is just to go for it. So hopefully what we got is a situation where the faster we move, the more dust we kick up. Yeah. So you can see there's a little bit of movement, but the problem is that it is not located in the position that we want it to be located in. I guess the solution for that is to add the velocity to the location. Because we're not really pushing it. Ob says, what IDE is this? This is Writer, and this is Sight. Sight is a really low weight IDE that I use when I don't really want to open up anything burly. It's basically Notepad, but it has language buffers or language highlights in it, so you can use it for HTML editing or JavaScript. It's perfect for when you're not doing anything big. You're just doing like one tiny little thing. You just use Sight. Oh, that's definitely better. Yeah, that's much more in line with what I was thinking. I won't say it's convincing yet, but that's definitely more in tune with what I want. All right, so we're going to go ahead and call that okay for the moment. What we're going to do next is get that to work with our, well, there's a couple of things we have to do. One is we should really add it to all of our sand puffs. And in order to do that, we're going to need a helper function. I think this is it. If we do autofind, all we really have to do is, oh, fuck, I was just trying to close a window, and obviously that meant that Unity had to recompile the entire project. Close. There we are. So all we really need to do is say particle renderer equals get component particle renderer. And then we say mesh renderer equals get component mesh renderer. There we go. And with that in mind, what we can do is we can just grab all of the other sand puffs. except for the one that we were editing. Yeah, so not sandpuff silt 6, but the rest. And we're going to go ahead and add that to them. That was called scripts life large moving object reaction. Just drop that in. And then we can tell it to auto find doom. And that should work differently for each of them, so we don't have to drag and drop a whole bunch of crap. We also need to take the sand cannon into effect. So we'll just do that again. Boom. So now that we've done that, all of the silt in this area should properly react to the player kind of swooping by. But let's go ahead and just adjust these values back a little bit. They were kind of high. That's a little bit low. Let's make it 60. This, however, needs to be created now. This is our seaweed. We're using this vertical seaweed shader, which we need to do the exact same setup for. Difference being, this is a much more complicated situation. And one of the things that's more complicated about it is that it is not a particle, which means that local vertex offset is, in fact, local. It also has some built-in vertex offsets, as you can see. So we're going to have some fun adding to this nonsense, right? Might as well get started. Just pop on over here. Create ourselves a property array, a global array, which we're going to name the exact same thing because that's how it all works. It's going to be a float vector 4 with an array length of 5. Then we need a custom expression. Serpent9 says you want the seaweed to be pushed. Well, I just want it to get out of your way to respond to your existence a little bit. That's the idea. Because it feels a little bit strange if it doesn't, right? At least it does to me. We're going to need to get a vector position here. Now this is local vertex position. We need to convert the local to a global so that we can do this in a global position situation. So for that we can just world our local to world matrix. Transform. I can't remember what it's called. There we are. Transform position. So this takes it from object to world, and that will give us the value we need. So here we're going to go ahead, and this is going to be a float 4. I guess it doesn't matter. And this one's going to be a float 3, which we're going to call pause. And this is going to output a float 3. And then we're just going to put these in. Why is this? That should be a float 3. Why is it just one line? Shouldn't it be 3 lines? Huh. Anyway, when it comes out, what we're going to need to do is the exact same thing in reverse. World to object. And it's also not going to be a transform position, so I don't know why I did that. It should be a transform direction. Why isn't it properly giving me the triples? This is a float 3 output. Why isn't it doing the 3 lines? I don't like it. It's all screwed up. Anyway, we then just bring this down all the way over to here. Wait, did I change something? I must have clicked on something while I was desperately trying to figure out. Because all of them are wrong now. These are all single lines now. I really loved it when I was doing the triple lines. How did I break that? Annoying. Oh well. Alright, so now all we need to do is get the custom expression correct. This is the custom expression we were using. It's very close to correct, but the only difference here is that we don't need to do the sine wave stuff. So we're going to go ahead and grab this and create a new file and paste it in here. And what we're going to do is we now have a value between 0 and 1, like this. With our value between 0 and 1, we need to invert that. And this is familiar because it's the first thing we did, right? So this is just the same basic setup. No biggie. Gonna go ahead and copy that, paste it in here, save it all. Now the only issue here is that this is actually pretty expensive. Because we're not passing it to the shader, we're passing it to the renderer. Shit. If we could pass it to the shader globally, like if we could target the shader for an update, or even the material, that would be much, much easier. Let me go ahead and see whether we can. So we do have the option to set various values: color, float, buffer, matrix, float array, matrix array. Set color array. It takes color values. I mean, technically a color is just a float 4. So that might be what we want. Oh, there it is, vector array. So we can set the vector array directly. See that? So we're going to go ahead and add in a material as well. Exciting, right? So in theory, we don't have to go and set it on every single piece of seaweed on the planet. We'll just put it here for now. We'll just put like a couple of exclamation points after it to make sure that we understand something exists. And then we can pass this a material. The material in question is, I believe, seaweeder. Vertical seaweed north, and I think we've also got a vertical seaweed east, so we'll just go ahead and pass it the vertical seaweed north for now. Boom. So if we grab the character, move them closer so we don't have to wait quite so long. Now, in theory, all of the seaweed should now get pushed. And it should get pushed more the faster we do it. Yeah. Obviously, it needs a little bit of work. I think it's actually going the wrong direction, which makes sense because we were multiplying it by -1 before. And so we need to not do that anymore. So let's just go ahead and fix that real quick. Here it is. Grind. Yes. I shouldn't have put myself directly on top of a plot point. That's fine. So push it real good. Oh, that's really not quite right, is it? So the issue here is that it's really, really obvious that it's like forming a circle around the player, a sphere around the player. Maybe if I were to remove the y-axis elements. Let's go ahead and remove the y-axis. I think that I put that in the wrong spot though, so we'll have to I'll have to see. I might move it down a couple of lines. Because we're normalizing after we remove the y-axis, which means that we're going to get some extra bump when we're doing motion on the things that are not on the same level as us. We'll see. Yeah, see that extra bump? That's not what I want. Swimming straight through it definitely causes issues. Maybe what I should... No, that wouldn't work. Sorry, I'm trying to think about how to do this, and I'm not having too much luck. Don't save it, just copy it. Dum-dum-dum-dum-dum. Ba-dum-ba-dum-bum-ba-dum-bum. I think that we are going to need to change the arc. These things currently, when they're near you, they react their most aggressively, which is creating a really pretty awkward shape sometimes. So I think what we really want to do here is, see, that's almost what I want. It's as good as it was before, I guess. But what I think we want to do here is we want to create a certain max, because we're getting some really weird effects near the player when we like push straight through them. So I think what we want to do is, instead of getting it between 0 and 1, we want to remap it to be between, well, it's still between 0 and 1, but it is it's going to max out at a different range rather than the range we've got now. So to do that, we'll go ahead and take this range of 1 minus 0, and we'll say range equals, if we say 1.5 times range divided by pushers, that'll give us a value between 1.5 and 0. And then we can just say if range is greater than 1, range equals 1. We can also use maxes and mins. Range equals max range 1. I'm not sure whether or not range exists. We'll find out in a moment. Max, I mean. I'm not sure if max exists. We'll find out in a moment here. I have the same signed unsigned error, but I don't see any issues with it not understanding max. So that should, except for I'd screwed that up, didn't I? I actually needed it to be the other way around. So this will get us a value between 0 and 1. But the thing I got wrong here is that we actually need a value that's the other direction. So once we have a range between 0 and 1, and then we flip it, we then have a range between 1 and 0, with 1 being when it's overlapping with you and 0 being when it's very far away. What we want it to be is, we want it to be 1 when it's overlapping with you and for quite a while, and then drop to 0. So the way we're going to do that is we're going to go ahead and multiply range by 1.5 here, and then max it. The idea being to make that fall off not exist, because that fall off was really distracting. I'm not actually sure if this is going to be any better, because I'm just kind of winging it. One of the issues is that these are very complicated objects, and you can actually sail right through them. Like, they're large enough and you're small enough that you can pass straight through a leaf. And if you do that, then the leaf will explode. It'll be like one vertex on a leaf will be pushed further right, one will be pushed further up, one will be pushed further down. And that's why we get a really aggressive... Oh, yeah. So you can see that popping. that popping is what happens when the leaf decides to split so that it's further away from you. Certain parts of it, certain verts of it, get further away more aggressively. Now, obviously, the real thing we're doing here is it's just that we need to change the values so that they're not quite as aggressive. But even if we change the values so they're not quite as aggressive, there's still a lot of popping going on. I guess our first step is to just reduce the size of the push of the pressure. So we'll just go ahead and bring that down. Oh, you know what the problem is? I figured it out. We're using the raw value for the vertex position, not the offset value. Oh, okay. So now I know what's wrong here. So you can see that we are all piling into this add and then this local vertex offset. The problem is that we're not taking that into account for our physics reaction. So our physics reaction is responding to a vertical column, and then we're moving the vertical column. So that's why it's not responding very realistically. What we need to do is we need to take this add, and we need to add that into our value before we do any of this calculation. So stop, just clear that. I don't want it. Here, there we go. So we're going to go ahead and register a value here, and we're going to call this non-physics offset. And then we're going to have another add value here, like so. And so over here, when we do this, this is our vertex position. It's in local space, but we're also in local space. So when we add in our non-physics offset here, that will get a value that is correct for our calculations. And then we can pull that in. So we'll go ahead and create a physics offset value. So all right, let's see if that's a little bit better. We're getting a lot of popping on the leaves still. It's a very clear, like, circle. I don't think it's working out. I might have to just not do this. I mean, I can reduce the effect as much as I want. Why is it so loud at the edges, though? It shouldn't be that... It should be, like, super, super gentle at the edges, right? That's kind of the whole reason I wrote it like this. I guess we don't need to put the other ones on. So there's a lot of changes I need to make here. So first things first, we do not need these large moving objects. The reason we don't need them is because we can simply use a large moving object script to set it once for the entire material. So if we put that large object script, we can just apply it to the material instead. And I believe we're using a puff material, sand puff silt. Can we get that to actually select? There we are. So if we just drop that in, it should affect everything in the world. We'll put them. But putting that aside, this is not working out quite right. There's something wrong with how we're getting it to do this stuff here. So let's take a look at the range, because I might have misunderstood what I was doing here. The range is the distance between the pusher and our current vertex. If the range is less than the pusher's diameter, then we divide it by the pusher's diameter. That's very clearly going to give us a 0 to a 1. But it's going to be 0 when it's near the player and 1 when it's at the edge. So we invert it. That way it's 1 when it's near the player and it's 0 at the edge. Then we multiply it by 1.5, so it ranges from 1.5 on top of the player to 0 at the edge. And then we max that to 1, so we end up with a third of the distance being 1, and then it drops off down to 0. Then we get the distance, we normalize it, we flatten it. All I can think of is that we must be screwing something up with the flattening of the normals or something, because we're getting a lot of chatter at the edges. I mean, we can multiply range by range. That'll reduce it, but that's such a strange thing to need to do. It doesn't seem right. There's something else going on here. First, let me just put a comment in here. Call this physics stiff. First, let's check and see whether it works on the silt. Oh no! Yeah, it works on the silt. So we don't want to have it per mesh renderer. That was a mistake. Ooh, that was some slowdown. We only want to have it per material. That'll be much, much cheaper. So as we get close to these guys, ooh, so you can see that they really don't, it really doesn't work very well, does it? So like a shutter runs through them. See that? And then they react. It's almost like they're still doing a sine wave. But there's no sine waves. I'm not sure what's going on here. See that initial shutter and then they do their pulse? That initial shutter is what's really confusing me, because there shouldn't be an initial shutter. There should just be a pulse. And I mean, the pulse is awkward. But I could work with that if I could get that initial shutter to not be there, because that initial shutter is so weird. What's with that chatter? I don't see any sign in the code of what's causing that initial sudden chatter. It's not something I get. But one of the other things we want to do here, we would like to move away from the player in a direction that's uniform. So let's try a little bit more stuff. I don't think we're going to want to do this explosive thing. The explosive thing is not working out. So if we take the vert position for these elements, and then we use that as the baseline, we're going to have situations where when we pass through a large object like this, it ends up pushing all of the verts away from the player, which makes the object bigger. And that's really not what we want. So what I'm thinking is we can offset it based on the object's world position. And so to do that, we can just add another input here. We'll call it transform. There we are. call this vert. And then we're going to want to get that object position. I mean, we can just use this. It's at 0, 0, 0, so it'll work. So once we have we could also just use transform position. I think that these are equivalent, but this one has fewer arguments. It doesn't really matter. Let's go ahead and use the same one twice. That'll just be a little bit cleaner. So 0, 0, 0, meaning the root of the object. And then when we come into the custom expression, we just have to change it some so that it uses that for the offset instead. So all of this part's the same, except for the pause value is changed a little bit. It's now called vert pause. And down here, we have the range, and then what we need to do is get the correct offset. So the offset is pause minus pusher, and that's what the problem is, because we don't want it to be pause minus pusher. We want it to be, I call it transform pause or object pause. Transform pause minus pusher. That will be the center, that'll be the root of the object to the element in question, and then we want to offset .y equals 0 there. And that'll get the x and z offset, the flat offset, towards the player. We normalize that, and then we push. Let's try it. I don't see any significant errors, so let's see whether or not things work. The only issue here is that these seaweed really wander pretty far. So that means that what happens is we're going to have a lot of drift, and that could mean that it pushes in a very weird direction. Let's find out. Well, we're still getting an initial, like, pulse. I'm not sure what's up with that. But the good news is... Oh, you know what that initial pulse is? Okay. No, it's not what I thought it was. Okay, so I think what's happening here is I'm offsetting the position by the velocity, which means that it's in front of us. So what I think is the initial pulse is actually the first front wave, and then the back wave is it coming along on the inside. I think you can see that, right? So there's no such thing as an initial pulse. It's just that it looked that way because of the confusing way it was processed before. Now, obviously, this is much, much wider than it should be. And the reason for that is because the scale is linked to the speed of the character. And it's supposed to kind of simulate a kind of massive push. So we're just going to offset that to reduce the scale and use a smaller range. Yeah, so I guess we'll just go ahead and say now I'm hoping I'm not creating an incredibly expensive shader here. It's quite possible that I'll have to go back in and tweak all of this because it's just going to be too expensive, but we'll find out. Gotta learn these things by doing them, and if they don't work out, you do them another way. All right, so here we go. Shtabloof. All right, so someone's making their loudspeaker noises next door, so I think that there's a party about to start. Probably stop streaming pretty soon here because of that. Okay, so you can see that we definitely have some issues. So the issue that we have here is that we're offsetting by a full second into the future, which is creating a lot of really awkward situations. What I might do is simply reduce it on the script side. I might like make it so that in world it doesn't push this far forward, but we're running into this issue where I don't think we're ever going to be able to fix this with this approach. I think we need a different approach. Maybe I should multiply it by the leaf radius or something, because I don't want you to push the whole thing. Well, I do in some situations. This is not working though. So what we're going to do is we're not going to use this. This, no good. So all we really have to do to get rid of that is to delete these. Pachoof. There we are. That's now put on hiatus. And I'm going to stop now because I'm hungry and my neighbors are getting loud. So I hope you have enjoyed this complete waste of time with me. And see you Saturday or next Wednesday. Bye.